Let's be real. When you're writing Java code, things are gonna break. It's just a fact of life. But what really separates a beginner from a pro is knowing how to handle those moments. So today, we're gonna break down the Java exception hierarchy. You know, mastering this isn't just about passing your next exam. It's a core skill for writing stable, professional code that doesn't just fall over at the first sign of trouble. So let's get into it.
So let's start with a big question. Why? Why doesn't every single bug or error just bring your entire program to a crashing halt? Well, the secret is that Java has this really sophisticated system for managing problems, and it's what lets our applications handle issues gracefully instead of just, blowing up. That system is the exception hierarchy, and that's exactly what we're about to map out.
All right, here's our game plan for today. We'll start with the why, the idea of a code safety net. Then we'll meet the granddaddy of all Java problems. After that, we'll get into a big one, the unfixable versus the fixable. Then we'll look at what the compiler makes you do versus what it leaves up to you. And finally, we'll pull it all together and see why this hierarchy is so crucial for you as a developer.
Okay, first up, the code safety net. I want you to think about exception handling as exactly that, a system that's there to catch your code when it inevitably stumbles or trips. You see, the key idea here is that an exception isn't just some generic error message. No, it's actually an object, and that object carries a ton of information, like what went wrong, where it happened, and why. And that structure is what's so powerful, because it lets us write specific code for specific problems, kind of like having a different plan for a network failure versus a file not being found, all while the rest of our app keeps on running.
To really truly understand this hierarchy, we have to start at the very top. So let's go back, way back, and meet the original ancestors that every single error and exception in Java comes from.
Everything, and I mean everything that can possibly go wrong and be thrown in a Java program, comes from this one class, Throwable. Now here's a cool little piece of trivia. Might even help you on an exam. You know how most things in Java ending in able, like runnable, are interfaces? Well, Throwable is the big exception to that rule. It's a class. And from this single parent, two major, very different branches emerge.
And this brings us to the first and most fundamental split in the entire hierarchy. This is the difference between things that are totally out of your hands and things that are absolutely your responsibility to manage. We're talking about error versus exception. Okay, this slide is so important. Really lock this in. On the left, we have errors. Think of these like a catastrophic system failure. The bridge is collapsing, the power grid went out. It's something you just can't fix from inside your code. But on the right, we have exceptions. These are more like a flat tire. It's a problem for sure, but it's an application level issue you can anticipate and, more importantly, recover from. A file isn't found, a network connection drops. These are the things you're expected to handle.
Just to make it super clear, think about out-of-memory error. That means the Java virtual machine literally has no more memory to give your application. Or a virtual machine error, which means the JVM itself is broken. See the pattern? These are problems with the environment your code is running in, not problems in your code's logic. That's why you don't try to catch them. Your app can't fix a broken system.
Now we get to the distinction that you, as a developer, are going to deal with every single day. Because inside that fixable exception branch, there's another major split. It's the difference between problems the compiler forces you to deal with and those that are considered your choice. This is checked versus unchecked exceptions.
And this is totally by design. It's a core piece of Java's philosophy. The creators of Java figured that some problems, like trying to read a file that might not be there, are so common and predictable that the compiler should force you to have a plan. But other problems, usually the ones caused by our own logical mistakes, are left up to us to avoid in the first place.
Okay, pay close attention here because this is a classic exam topic. On the left, checked exceptions. Think of the compiler as a super strict supervisor. If your code tries to read a file, the compiler knows that file might be missing. It will literally refuse to compile your code until you handle that possibility. It is compulsory. But on the right, you have unchecked exceptions. The compiler just doesn't check for these. It trusts you not to make these kinds of mistakes. And I am willing to bet you recognize these guys. Trying to divide a number by 0? That's an arithmetic exception. Trying to access the 10th item in an array that only has 5? Array index out of bounds exception. And of course, the infamous null pointer exception, when you try to use an object that doesn't exist yet. These are all programming mistakes, which is why they're unchecked. The compiler just assumes you'll write better code.
So, we've walked through the entire family tree. We've seen all the branches. Now, let's tie it all together and really understand why this structure isn't just academic, it's fundamental to writing good, professional code.
This table right here is your ultimate cheat sheet for revision. Let's do a quick lightning round. First, error. A severe system failure. Do you handle it? No way. Second, checked exception. A predictable problem like a file not being found. Do you handle it? Yes, it's compulsory. And third, unchecked exception. A programming mistake. Handling it is optional. But honestly, the real solution is just to fix your buggy code.
And this quote just nails it. It really gets to the heart of the matter. While the compiler says handling unchecked exceptions is optional, in the real world, it's not. A good programmer thinks ahead, anticipates potential failures, and writes code that can recover gracefully. That's what keeps the application running and what keeps your users and your clients happy.
So the ultimate takeaway is this. Great software isn't about the perfect scenario where everything just works. It's about building code that's robust enough to handle the unexpected. Understanding this hierarchy, from throwable all the way down to errors and the two types of exceptions, gives you the blueprint to build code that doesn't just work, but code that lasts. Your code is only as strong as its ability to handle what goes wrong.